Students, wake up or I'll hit you. This is the esteemed Cavendish Laboratory, which for unknown reasons today smells like Limburger cheese. It is not a doss house in Epping for Essex girls with a case of gonorrhea and a hangover. So sit up, pay attention, or I'll give you the clap. Today you will once more have the pleasure of my reading the notes of your latest missing lecturer. Unfortunately, your lecturer cannot attend this morning's reading as he was last seen falling off, the gherkin dressed in only a gimp suit. Best if you don't ask why. And believe me, I don't want to be here any more than you do, but those bloody deranged homunculi down at Job Search Plus just don't believe me when I tell them I'm just waiting to be offered the part of King Lear at the Croydon Amateur Theatrical Society. So, once more they have sent me down to Cambridge to read these bloody lecture notes in theoretical physics yet again. Me, a great Shakespearean Thespian who once played Puck in A Midsummer Night's Dream at the Brighton Panto. I mean, what are they thinking? I didn't just play Puck, I was Puck! Talk about interpretive dance! Now sit down. First, we start with Galilean invariance, or as I, an esteemed Thespian with absolutely no credentials in physics, like to call it, the universal rule of you're not going to notice squat unless the boat gets wobbly. Picture it, if you will. The year is 1632. Our boy Galileo, beard on point, brain firing on all cylinders, is on a ship. And not just any ship, a perfectly smooth-sailing ship, cutting through the water like a swan through wine. Below deck, he thinks, wait a minute, if I were down here, no windows, no creaky planks, just me, my wine, and maybe a dice game, how would I know if the ship's moving? Answer, you wouldn't. That's right. Galileo's big eureka moment wasn't some fancy math or celestial revelation. It was realizing that if everything's moving steadily and smoothly, it's basically like you're standing still. Genius, right? I mean, relatable too. I once thought I was standing still at a party, but I was on a revolving dance floor the whole time. Same vibe. Now, in the world of science, they call this concept Galilean invariance, or sometimes Newtonian relativity, because Newton swooped in later like, hey, cool idea, Galileo, I'll just sprinkle in my laws of motion and make this official. And so he did. Here's the gist. No matter which inertial frame you're in, that's fancy physics talk for somewhere cruising along at a steady pace without drama, the laws of motion don't change. The math stays the same. Throw a ball, drop a feather, take a nap, it all behaves just like it would if you were chilling in your grandma's living room. Newton also decided there's this thing called absolute space. Like, somewhere out there, there's a big cosmic grid where everything is truly still and everything else just zips around relative to it. Sounds poetic, right? Like the universe's eternal dance floor. But don't get too attached, because Einstein came along centuries later and was like, actually, Newton, space and time are doing the cha-cha together, and your grid is a lie. Oh, and let's not forget universal time. Newton said, everybody's clocks are ticking the same, no matter where they are or how fast they're moving. Galileo probably nodded along, sipping his wine, because back then nobody was arguing about time zones or daylight savings. But now, thanks to Einstein again, we know time can stretch and squish depending on how fast you're going. Time itself was just as wobbly as this actor after 2 martinis. So to sum up, Galilean invariance is like being at a really chill party where the vibes are steady. The DJ's playing smooth tracks, and you can't tell if you're moving unless someone rocks the boat. It's a beautiful, simple principle. No drama, no fuss. Just pure, unshakable stability until someone spills their drink. Or Einstein shows up. Let's consider the principle of relativity, a majestic idea in physics that essentially says, no matter where you stand or float or zoom through space, the rules of physics don't play favorites. Simple, right? Wrong. For someone like me, it feels like trying to learn chess from a cat. Mind you, not Benedict Cumberbatch's cat. Even Marlowe's dead, tortured body is more relatable than that bloody cat pissing on your leg every 5 minutes. But back to relativity. Apparently, this principle insists that the laws of physics have to look the same to everyone, no matter where they're standing or how fast they're moving. Sounds fair, but also, isn't that kind of like saying rules should be the same, whether you're playing in the kitchen or the living room? Sure, but then Einstein comes in, flips the board and says, by the way, time and space also bend depending on how you're sitting on the couch. Special relativity, oh boy, here we go, states that physical laws should hold in all inertial frames, which is science speak for when you're cruising along without hitting the brakes. So if you're flying in a spaceship at a gazillion miles an hour, the laws of physics are like, cool, same deal as when you're chilling on Earth. But if you dare to accelerate or, heaven forbid, decelerate, suddenly things get complicated. The laws might toss in some fictitious forces, which are basically physics' version of imaginary friends, only less friendly and more mathy. Imagine, if you will, Act 1, Special Relativity. A world where the speed of light, yes, that Quicksilver constant, is the only unshakable truth. No matter how fast you sprint, drive, or fly, light always races ahead, refusing to be caught like a diva who's sworn off autographs. Einstein steps onto the stage of science and proclaims, away with your notions of absolute time and space. They are but illusions, props on a stage that bends and twists with the motion of the players. What does this mean? Picture a clock on a speeding train. To the passenger on board, it ticks as usual. Tick-tock, tick-tock. But to the student standing on the platform, watching that train zoom past, the clock's ticks appear stretched and slowed. Time, dear students, is no longer the steadfast guardian of order. It's more like that one group project member who suddenly decides to take artistic liberties with the schedule. And space! Oh, space! Once thought to be a steady, unchanging backdrop, it too gets dragged into Einstein's act. It's no longer just there, but dances alongside time in a unified space-time extravaganza. Move faster, and space contracts, time dilates. The faster you go, the more the universe seems to say, don't trust your instincts, trust the math. Next, we must address general relativity. I have to do this, otherwise Job Search Plus will block my payments. So that's where we are headed, even though I have no idea where we're going, how we got here, or even who I am. I mean, seriously, I drank so much vino blotto last night, I've forgotten my name again. But yes, back to the reading of Einstein's general relativity. Gather close, dear students, but not too close. I don't want to smell you. And let me, your overly dramatic instructor, guide you through this grand opera of space and time. A tale where common sense takes a bow and the impossible becomes the star of the show. This one is like special relativity's overachieving younger sibling. It says all frames of reference are valid, even the wobbly ones, because space-time itself is like a giant trampoline. Step on it too hard with your mass. Looking at you, the intellectual black holes in the back row, and everything else has to bend and roll around you. Einstein must have had a great sense of humor to suggest that gravity is just objects rolling downhill on this cosmic bouncy castle. Now, Einstein takes the drama to celestial heights and exits pursued by a bear. No longer content with redefining time and space, he reimagines gravity itself. Imagine space-time as a vast trampoline. Place a bowling ball in the center. That's your planet, your star, your black hole. The trampoline dips, creating a curve. Now roll a marble along the surface. Does the marble go straight? Of course not. It spirals, trapped in the curve. This, my eager scholars, is Einstein's gravity. Not a pulling force, but the bending of space-time's stage beneath the weight of celestial actors. Einstein tells us you are not moving through space and time. You are navigating a fabric woven together and warped by mass and energy. Even light, the fastest, most stubborn traveler, cannot resist its curves, bending gracefully around stars in a cosmic ballet. Enter the black holes, those enigmatic prima donnas of Einstein's story. They are regions where space-time bends so steeply, not even light escapes. They represent the ultimate stage exit, disappearing behind the event horizon, leaving us to wonder what lies beyond. Of course, at this point, you're probably wondering, why? Why does the universe behave this way? Well, it's simple. Light. You see, light must travel at the speed of light. That's its thing. But when a photon of light hits an electron, they must be in the same phase for the interaction to take place. It's like an opera singer smashing a champagne glass with the right note. And, drumroll please, if the electron and the photon are in the same phase, then mathematically speaking, they are in the same frame of reference. Sum over all the electrons in a spaceship, and the ship confirms to the Lorentz transformation. And that peculiar fact is why we have the principle of relativity. Who would have guessed? Well, I certainly didn't, and I have no idea who puts these bleeding notes in these margins. Therefore, students, here's what you must take away. Einstein's relativity is no simple play. It's a production of cosmic proportions, one that continues to challenge, inspire, and occasionally leave us staring at the ceiling at 3 a.m. muttering, "How can time be relative?" Yet, it is in this challenge that we see its beauty, a universe not static, not simple, but alive, dynamic, and endlessly fascinating. In summary, relativity is a brilliant theory that unites space, time, and energy in a way that makes sense to physicists, but turns the rest of us into confused mimes. At least one thing's clear. Whether you're stationary or hurtling through space, you're still not going to escape the critics on opening night. Because just like the law of physics, bloody art critics are the same everywhere. And now we must discuss the real issue here, which is Benedict Cumberbatch, because I've had just about enough of Benedict Cumberbatch waltzing around like he's the center of the universe. And you know what? Let's talk about this scientifically, with some relativity, because I'm getting paid for this blithering nonsense, and even physics can't explain how that man manages to warp every project into a one-man show. Let's start with Galilean relativity, or as Galileo said, the laws of physics are the same in all inertial frames of reference. You're on a ship? Great, you're in a theatre seat? Same thing. And yet, when Cumberbatch steps onto the stage at the Old Vic, it's like the laws of performance are not invariant. Suddenly, every other actor's gravitational pull is obliterated, and the man becomes the sole celestial body in this supposed ensemble piece. Galileo never said, "All frames are equal except the one with Benedict in it." Einstein tells us that time and space bend around objects moving close to the speed of light. Well, apparently Benedict Cumberbatch has achieved some kind of theatrical light speed, because the moment he starts delivering a monologue, time slows down for the rest of us. His scenes stretch out, the runtime elongates, and we're all sitting there trapped in his space-time distortion, waiting for the plot to get back on track. Einstein said that massive objects bend space-time. Well, congratulations, Benedict, because your sheer presence seems to generate a black hole at the Old Vic. Every bit of focus, every ounce of emotional gravity gets sucked into the Cumberbatch event horizon. Try as they might, no supporting actor can escape. They deliver their lines with the fervour of someone hurling words into the void, knowing he'll never escape the pull of his smug magnetic orbit. It's not enough that he's Doctor Strange, Sherlock Holmes, and the bloody dragon from The Hobbit. Oh no! He's got to dominate every single stage production like he invented soliloquies. Meanwhile, the rest of the cast are out here working their socks off, bringing nuance and subtlety, but who cares? Because Benedict's emotionally tortured genius routine is eating the entire performance alive. And here's the kicker. When you point this out, people act like you're the problem. Oh, but he's so talented. Sure, fine, he's talented. But talent isn't supposed to steamroll an entire play. Relativity tells us that motion is relative. But apparently Benedict's ego is the one absolute constant. It doesn't matter where you're sitting in the theatre, it's always about him. So, Benedict, if you ever listen to this, maybe let someone else have a moment in the spotlight, because even Einstein would tell you that space-time isn't supposed to revolve around one person, no matter how good you are at playing emotionally distant geniuses with cheekbones sharp enough to cut space-time itself. Therefore, students, our little play comes to an end. What? Yes, I know, you wart-faced baboon. This isn't a play. I'm extemporizing. When I played Ophelia, I extemporized the whole bloody way through Hamlet, and nobody noticed. Probably because I wasn't chewing the scenery or bending space-time to make sure I was the only thing anyone could focus on. This is the takeaway. Relativity teaches us that the universe is a complex, interconnected web of time, space, and energy. An ensemble cast, if you will. And in an ensemble, every part matters. No one, not even a Cumberbatch, should be the sole star of the cosmic show. No, it should be me. So let's all strive to be more like the laws of physics, consistent, collaborative, and not entirely dependent on a man with an elfin-like grace brilliant enough to rearrange the whole of Minkowski's space-time into his own personal catwalk. And that, you grotty lowlife, barely human students, is the true lesson of the universe. Class dismissed. Now bugger off!